Okay. All right, so 2 sections in this unit, so it's going to go by quick. So sorry about that on one level, not sorry on another level. So we will have a test a week from today on 2 sections. I'm going to try to take it slow. We got full class periods for each section, no rush at all. And so again, as usual, questions, comments, concerns, let me know. Take your quizzes. I just went and reviewed the quiz grades. Please, 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 I beg you, take the quizzes so that at the end of the semester, that quiz grade bumps you up. Okay, I hate when quiz grades drop people down because that's not my intent at all. So section 8.3 is going to deal with 2 topics that we're going to go through. One is a very general topic and doesn't really change for anything. The other is a little more specific. I try to minimize the number of formulas that we're going to have to remember, okay? Because I don't like to memorize formulas any more than anybody else does. So we're going to talk about 2 things. We're going to define and deal with these 2 things. First, what perimeter is, and then second, the idea of the area of a figure. If you remember where we left off before the last test, we were talking about polynomials. And as far as we got with polynomials, is we talked about the names of different polynomials depending on their sides. We talked about the sum of the angles on the inside. So we're going to now extend that discussion to these 2 things. So the first thing, the perimeter. Yes, you will have to remember those things. But again, I'm going to try to make it hopefully a little easier to categorize this knowledge so that it's not as much to remember as you're hoping. That is my goal here. Okay, so perimeter, I don't want to make a big deal out of perimeter. I know that when you go some classes, previous teachers, there's all sorts of formulas for perimeter. What is, first off, in general, what is the perimeter of a figure? It's the distance around the outside. Okay, so the perimeter is the distance around the outside. Well, I'm going to make this as hopefully relaxing and easy to remember as possible. The way we figure out that distance is we just add up, okay, or we take the sum. The sum, if you don't know that word, sum just means to add up. We take the sum of all the sides. I'm not going to tell you a formula for perimeter, except for circles. That's a slightly different thing. I'm not going to tell you a formula for perimeter because as long as you know the sides, you just add it up. Okay, so if you know any formulas for perimeter, fantastic. That's even better for you, but you don't have to know any. So here's just a couple quick examples I want you to do. I don't think adding up the sides of something is too big of a deal. Here's our good buddy, the rectangle. Here's our good buddy, the rectangle. And so I'm going to label a couple of the sides, and I want you to find the perimeter. Remember, the perimeter is the sum of all the sides. It is the distance all the way around the figure. So on this rectangle, let's say I label the left side here as, let's say, 7 inches, and then the bottom side, let's call that 12 inches. Let me give you a minute or so to please figure out the perimeter. What is the distance all the way around that figure? All right, remind me, just from this figure, how many sides does this have? 4. I've only labeled 2 though. Sometimes that causes a little consternation, and I did that intentionally. Just want to make sure we do the right thing. So the perimeter of this, I am going to add up all the sides. That is the definition of perimeter. So this left side clearly is 7 inches plus. What's the top? I'm just going to go clockwise around. What's the top side? 12. Okay. What's the right side going to be? 7 inches. The bottom is labeled to be 12. So if you only did 2, if you got 19 as your perimeter, okay, the thing you need to remind yourself is the perimeter is all the sides, okay, whether they are explicitly labeled or not. Okay, that is a common mistake on the test. That's why I mention it, because I want you to avoid it. Now, when I add up 7 and 12 is 19, 26, we get 38. Another thing to consider is what are the units on this? Well, since I'm just walking around the outside of the figure, the units are just the units I'm given. It's a linear measure. Okay, so it's 38 inches. Okay. Units are important. If I give you units on something, if my math lab gives you units on something, units have to be part of the answer. Okay, that'll be a minor deduction on the test. If you just gave me 38 without the inches, I'll take a little point off or so, because I know you know what you're doing, but this is important as well. Okay, so again, we do this, some of this stuff, like I mentioned in the last unit, has application for some of you. That's why we've been asked as a math department to put it in as the test. Units are a thing that we've been asked to deal with, because if you're going into nursing, units definitely matter, right? Depending on milligrams or centigrams or whatever, that will make a difference between whether somebody lives and dies when you give them the medication. Okay, so continuing on, here's another figure. Want you to go ahead and figure out the perimeter of it for me. Here is a triangle. Okay, specifically, I'm going to give you a right triangle because while I've got it up here, that doesn't look right. It looks like it's collapsing. So let me try better. Oh, that's way better. I'm going to put a little right angle there. We'll talk about something else in a minute, but let's just say that I have this. Let's say this is 5 centimeters. This side is 12 centimeters. This side is 13 centimeters. Please figure out the perimeter of that triangle right there. Okay, so again, the perimeter is just the distance all the way around the figure. So it doesn't matter where you start. I'm going to start here on the left side. That's 5 centimeters. Then this side right here is 13 centimeters. Then the bottom is 12 centimeters. I'm hoping that the perimeter is pretty apparent. 5 and 13 is 18, plus 12 is 30. And then what are the units on my perimeter? Thank you very much, centimeters, perfect. I'm just going to have you do one more just to make sure that I feel like I'm being a good professor. Leave a little gap underneath this triangle in your notes. We're going to come back to this because I need to talk to you a little bit about right triangles. There's a special relationship between the sides of right triangles. I'm sure you know it. I'm sure you've seen it before at some point. There's not going to be a super surprise, but I need to mention it as well. Okay, one more. Just going to give us a slightly different figure. So let's say this figure here, we're going to talk about it. It's called a trapezoid. Fun thing about a trapezoid. Trapezoid has one set of parallel sides. So on this trapezoid that I've drawn, the top and the bottom are parallel. The left and the right side, there's no relationship between them. So a trapezoid has one set of parallel sides. The other two sides, there's no relationship. They could be anything. And so again, I'm just going to label the sides. Okay, I'm hoping that you're totally, completely bored because this is easy. Not bored just like because you're generally bored in math class. Okay, so I hope this is different boredom. So let's say that this trapezoid, we've got 30 feet on the bottom and 20 feet on the top. And then let's call this, I don't even know if this would work, 18 feet over here. And let's call this one 12 feet. Okay, just making up distances. I don't even know if that was a real trapezoid. All right, so the perimeter of this, the distance around, again, it doesn't matter what order you do this in, we shall have the same answer. I'm gonna, again, start with the left, just work my way clockwise. I've got 18 feet, I've got 20 feet, I've got 12 feet, and then finally 30 feet. And when I add all those up, the distance around 18, 20, that's 38, that's 50, that's 80, and the units are feet. Is anyone struggling with perimeter? Finding the distance around something? Is there a question, comment, or concern at all about perimeter and how we're doing this? Please, I know it's early, I know you're tired, you barely want to be out of bed, but if you have a question, it doesn't take a whole lot of energy to do that. Okay, one more thing about perimeter before we'll go back to that right triangle, and then we'll talk about area, which is the other thing for the day. The perimeter of a circle. So the perimeter of a circle gets a fancy math name. It's called the circumference. So here's my circle. I'm going to do my best. I should also tell you what a circle is, so I'll do that too. Oh, that's not too bad. It's a little elongated top and bottom, but not too bad of a circle. Let me tell you what a circle is, since I'm assuming that you know, and you might not. A circle is a set of points that are all the same distance from a central point. Okay, so the circle is a set of points, all the same distance, from a point called the center. So you can see I made a little dot when I was trying my best. That's not the best circle I've ever drawn. You can check out my Instagram at the Perkster. I put the best circle I've ever drawn. It's on there somewhere. So the center is not actually part of the circle. Okay, it is just the reference point. All of these points here on the outside, this is the circle. This is the set of points that are all the same distance from that. Now, a couple of trivia questions. Does anyone know what this distance is called from the center to the outside of the circle? The radius. Great, you've heard this. I'm boring you. I get it. The radius is that's what that's called. The distance from the center to the outside of the circle. Does anyone know what, I'm going to just draw this as a dotted line so not to be super confusing, what this line is called, or segment is called, that goes all the way from one edge of the circle to the other? It's through the center. Yep, it's the diameter. Great. I don't know if this comes up in this section, but it's great. It's great trivia. You can impress your friends this weekend when you're at parties. The diameter is a specific, specific version of what's called a chord. A chord is a segment that just joins any 2 points on the side of the circle. So this right here, this line right here, this is called a chord. So there's your circle trivia for you. So I promised you that I would show you how to find the distance around a circle, and it's really fascinating how the mathematician, I think it was Euclid, a Greek guy, long time ago, way smarter than me, figured out how to find the circumference of a circle. If we have time at the end, I'll show you, because it's really kind of an ingenious thing. But anyway, the circumference of a circle, which we'll use the letter C for, is equal to 2 times this number that we call pi. It's a Greek letter. It's got 2 little legs and a wavy top, in case you've never written one before, times the radius. That's the circumference of a circle. That's how you figure out the distance around the outside. So pi, you've probably seen all this before. Pi is called an irrational number. You don't need to know that at all. I'm going to leave this triangle right here. I'm just going to get rid of the perimeter. Pi is an irrational number, and we approximate it. That's what, when you make an equal sign that looks like it's an omin, that's approximately equal to 3.1415. That's a pretty decent approximation. If you have a scientific calculator, your scientific calculator has a pi key. So be careful when you're on MyMathLab. Make sure you're following their instruction for what to use so that you don't accidentally end up with the wrong answer. If they tell you to round to the 100th or the 10th or the 1000th, make sure you're rounding to the right place. And also make sure you're using the right approximation for pi. If they tell you to use the pi key on your calculator or on the MyMathLab calculator, make sure you're doing it so that you don't unintentionally have some round off error. If I know a lot of times teachers tell us 3.14 is a good approximation, but then you leave off everything coming. This is a better approximation. If you add more digits, it's an even better approximation of what pi is. Fractionally, sometimes people say 22/7 is a good approximation of pi. I don't think MyMathLab will have you use that, but if you're working with fractions, that sometimes works out. But again, here's the thing that I want you to understand about pi. These are not equal to pi, okay? In fact, if you feel a little geeky over the weekend, okay, look up digits of pi or pi wallpaper. Somebody has printed out or allows you to print out the first million digits of pi so that you can, you can put it on your wall and just feel good about yourself. There's interesting things about the digits of pi. I won't bore you with that. You're probably already really bored. All that to say, these are not the actual values. Okay, so these are approximations that we can use to approximate our answers. So just be real careful when you're using MyMathLab. So I'm going to do an example here, and then I'm going to have you do one, and then if you feel good about circles and their circumference, then we'll move on back to our right triangle. Okay, so I'm just going to erase, I'm going to try to draw a new circle. All right, so we're going to find the circumference of this circle after I draw it. That's a little better than the previous one. Okay, so we're going to say that this circle right here, let's say that it has a radius of, let's go 35 inches is going to be the radius of that. And here's what I want to know. I want to know what's the distance around. Okay, how far around is that going to be? So I'm going to do this first one just to get us used to how we're going to do this. So what the instruction I'm going to give you is we're going to use 3.1415 for pi. And then we're going to round our answer to the 100th. So here we go. The circumference of this is 2 times pi. Oops. That after 2 times pi times the radius. So I'm just going to, once I got that in my brain, I just got to plug and chug. So here we go. 2, I'm going to use 3.1415. On the test, I will tell you to use either 3.1415 or if you have a scientific calculator, use the pi key. Okay, either one is going to be fine with me. And then times the radius here is 35 inches. So then just make sure you're comfortable with your calculator. I didn't bring a calculator because I wasn't super prepared, I guess. So here we go. I've got 2 times 3.1415 times 35. That's 219.905. The 100th is the second decimal place, tenths, hundredths, thousandths. Okay, so I'm going to start with the second, or I'm going to round to the second decimal place. So that's going to be 219.91. And just like with our perimeter, since it's the distance around, it's a linear measure, it's inches. All right, so here's yours. If you have any questions about that, basically it's plug and chug. It's using this formula. So do enough homework so that you can remember 2 pi r is the circumference. Again, I'm trying to make as few formulas for you to remember as I possibly can. Okay, I don't get any joy out of having you memorize stuff that is not necessary. So here is your circle. I'm going to give you one. This one's going to have a diameter of something. Let's say that it has a diameter of let's go 107 millimeters. And I want you to figure out the circumference of that circle right there. Same conditions, 3.1415 for pi, or use your pi key on your calculator and round to the 100th. Okay, so circumference is 2 times pi times the radius, 2 times 3.1415. Now, I gave you the diameter on this problem, 107. What's the radius of this? 53.5.
So it's half.
Yep, that is great. So if you didn't know that relationship, the radius, as I mentioned earlier, goes from the center to the edge. The diameter goes from one edge to the other through. So the diameter is equal to 2 times the radius. That's the relationship. Okay. Now, if any of you are awake and alert, or you've done this before, but I'm not trying to make up too many formulas for you. You might have seen, hey, Herster, 2 times the radius, that's the diameter. Could I just use the circumference as pi times the diameter? And the answer to that question is yes, you certainly can. Okay, so if you're given the diameter, you could just do pi times that, but I'm just trying to streamline things for you, that's all. So that's why I didn't mention it at the top of the problem. So now my circumference is equal to, and it's a calculator problem. I'm just going to throw this down in my calculator. You can compare your answer with my answer, and if you have any questions about why yours is different than mine, let me know. 2 times 3.1415 times 53.5, and that turns out to be rounded to the 100th, 336.14 millimeters. If you use the pi, let's see if we get something different. If you use the pi key on your calculator, because the pi key has more decimal places, so it's going to be a little more accurate. So there might be a little what's called a round off error. If you take any science classes, they will give you lots and lots of instruction about how to avoid round off error. So let's see, 2 times my pi key. Where's the pi key on my Apple phone here? There it is. There you go. And then times 53.5. Yeah, so if you use the pi key on your scientific calculator, you get 336.15 would be your answer. And that's more accurate than this because there's more decimal places. So either one I would accept on the test. Yeah. Okay, so we'll get to that. Just one second. Before we get to that question right there, anybody uncomfortable with the circle and its circumference? Are we okay?
So
yes, that will. And another reason why I present it like this is when we get to the area formula for the circle, you have to use the radius. So in my mind, I'm like, if you always use the radius, if you get used to that, then it's only one thing you have to learn. So that's, again, I know memorizing a lot of formulas in a week is not a great thing, so I'm trying to minimize that. All right, so before we go on to the Pythagorean, or excuse me, I just spoiled the surprise, the triangle right there, rounding. All right, so let me just write well, let me do 2 things. Let's just do a general rounding, and then I'll remind you what the places are called on our decimals, and then we'll be good. So let's say we have this 5,439. And I ask you, let's round this to the tens place. Well, what number's in the tens place? Lots of options.
Where's the decimal point?
There's no decimal point. It's just a whole number. Okay. This is my units. This is my tens, my hundreds, my thousands, my 10,000s, my 100,000s. Okay, so we need to have also a conversation about how things are numbered. When you talk about the numbers, okay, it goes in groups of 3. We have a really nice system. Okay, it took thousands and thousands of years to develop all around the world. Contributions from every culture to how we do this. Okay, so this is our units, our ones place, our tens place, our hundreds. And then we go groups of 3. That's why we use commas except for 4-digit numbers in our system. So let me draw. Let's do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll do some commas here. Okay, so ones, tens, hundreds. Great. Then the next group of 3. What are these groups of 3 called? The thousands, right? That's what we hope our yearly salary gets up in this range here. So this is ones, so 1,000s, 10,000s, 100,000s. You see how it repeats? Every one, it goes ones, tens, hundreds. Then what's this group called? Don't forget me if that becomes your yearly salary, okay? Remember how much I enjoyed you guys. Okay, so then it's 1 millions, 10 millions, 100 millions, and then we get up into you know, national debt category right here. So if I added another 532 right here, so we've got our units, we've got our thousands, our millions. These are what? Billions, and 1 billions, 10 billions, 100 billions, and then trillions and all that stuff. Okay, so those are our place value names. So I asked you, let's round this to the tens. What number now you can say confidently is in the tens place? 3. Thank you very much. So this is our tens place. So to get to the question, what is rounding? The rule for rounding is this. If the number behind it is 5 or more, you round up. Okay, so this one, when I'm looking at the 3, what's the number behind it? A 9. So that tells me when I round, I make this a what? 4. Okay, so this becomes 5, 4, 4, and you put a 0 on there. Okay, because you have to have your ones place. Okay, if I asked you, let's round this to the 1,000. What number here is in the thousands place? 5. Okay, so I'm going to erase my arrow. I'm going to put this here. So I look behind that. What number is there? A 4. What does that tell me to do? Stays the same. You don't do anything to this number. Basically, you're saying, what's it closer to? What's the rest of this closer to? Is it closer to 0, or is it closer to, or is this number, is it closer to 5,000, or is it closer to 6,000? That's the question we're asking. Okay, and so we keep it the same. What it's called is truncated. So we are going to leave it at 5,000. Those are the rules for rounding. So then, just like, and this is why I guess this is why I confuse things. So let's say that we have point, we got a decimal place, and then we've got 3, 4, 9, 7, 2, 8. Well, if I put a 1 here, so I've got 1.3492. So again, we go groups of 3s. So this is my ones place. Then this becomes my tenths. Okay, so all of these are the same word that we used for the others, but with a ths. So you spit on people when you say it. Okay, this is the tenths, the hundredths. So it's spelled HUNDRED with a THS on the end of it. All of them have a THS on the end. So that's my hundredths, my thousandths, 10,000s, 100,000s, and then it goes the next group of 3. Millions, 10 millions, 100 millions. Okay, so some arithmetic for you. So if I asked you to round this to the hundredths right there, that's this number, what's it going to be? Yep, it's going to be a 5, because this is a 9 right there. So that means 1.35. Better?
I was really laughing because you were just thinking, but
Sorry, I probably shouldn't even do that in the area code, but I wasn't really spitting, I promise. Okay, there was no spray here. If you feel like it, I could spray you with this, okay, and we'll make everything better.
So that's the hundredths on that side. Because to me, I don't want to say that's the tenths, because after the decimal point, like I'm thinking.
That's why I put this in here. This is no matter what, this is the ones place, right here on the left side of the decimal. So that's the reference point either way. So this is the ones, and then if there was another, this is tens. And then this would be hundreds.
Oh.
Okay, notice no THS. So then this becomes the 3 here is in the tenths. And I know this is getting messy, I'm sorry. This is the tenths place, hundredths place. Okay, but everything is referenced with the units, the ones. Better? Did I add more confusion, or did I clear up your confusion? We okay? What'd you say? Tad more confused, or a tad better? Okay, what's confused? Uh-huh. Uh-huh. Okay. So they're just called different things because these are whole parts and these are parts of a whole. These are like, this is the, if we're thinking money, these are your cents, right? So that comes after the decimal. So that's, and so, and our money stops at the hundredths place because our dollars are divided into 100 cents. So that's why we stop at the hundredths place. So 34 cents. Okay. So these are the wholes. These are the parts over here. The decimal separates them. Okay. So that's rounding. you need more help with rounding, I got some resources. I can provide you a little more help with rounding. That's not a problem. Okay, so what we've talked about up to this point, just to refresh, we've talked about perimeter. Okay, we've talked about perimeter of straight-sided figures, like we did trapezoid, rectangle, we did squares, we did triangles. We talked about the perimeter, which is called the circumference of a circle. So now our transition before we get to the area, which was the other thing I promised you today. I said leave a little gap in your notes for this thing right here called a right triangle, because there is a very famous relationship historically about the sides of a right triangle. And we attribute this to a Greek dude because he was really interesting even beside this. It's called the Pythagorean Theorem. And what the Pythagorean Theorem says is this: is for any right triangle, if this is a right angle, and that's the key, it has to be a right triangle. The letters that are usually associated with the sides is these two sides that surround the right angle. They are called the legs of the right triangle. You don't have to remember that. It's just fun. It's fun trivia. And the letters that are usually used are the letters A and B. You can use anything you want, but A and B are the traditional ones. The long side, that's on the opposite side of the right triangle. I just recently learned how to spell this. The hypotenuse. It's a fun math word to say. And the traditional letter for this is the letter C. So the Pythagorean theorem, the Pythagorean relationship says this: if you take the square of each of the legs and add them together, so these are my legs, and I square them and I add them together, my legs, then that is equal to the hypotenuse squared. Now, I'm not going to do it for you, but Pythagoras had a really cool little theorem. But I just want to show you visually what he was doing. Because back in the days of Pythagoras, they didn't have this cool notation. Like I said, this took thousands of years to develop, and we are the benefactors of it. Back in his day, if they wanted to talk about multiplication, they actually drew a picture. So when he presented this, he said if we draw a square, okay, of length this side and a square of length this side, then the area of this square and the area of this, when I add these two areas together, it would be equal to the area. And I didn't plan very well, so forgive me. I'm not going to write on the paint. They'll fire me for that. That's equal to the area of this square right here. So when he proved this relationship, that's why it's attributed to him. There's evidence that other people groups before the Greeks used this relationship, but Pythagoras is the one that actually proved that it has to be true. That's why it's named for him. The areas here equal this area. He had a really clever proof to that, but I just think it's interesting that back then, the way they thought about multiplication was as a picture of a rectangle, whereas when we think about multiplication, we do 2 times 3. But what they would have done is they would have said, oh, 2 and 3, that would have been how they notated multiplication. Anyway, history of math, if you got to take a history class and you can find a place that does a history of math, it's super fun. There's a lot of cool stories in the math world. I know you wouldn't believe that, but Pythagoras also had a math cult, and he famously was fond of executing people that didn't agree with him. So he wasn't really a nice guy either, but that's a whole other story. Anyway, so here's how we're going to apply the Pythagorean theorem, and then we'll get on to area. Is this. Here's my triangle, and let's say, here's a nice relaxing one. I'm going to say that this side right here is 3. I'm going to say the hypotenuse is 5, and then I don't know what this side is. So this is how we're going to use the Pythagorean theorem. Just a couple nice, quick, little cute examples. What we're going to do, we're going to do one together. I'm going to give you one to do. We are going to use the Pythagorean theorem, that relationship, to figure out what the missing side of this right triangle is. Okay, so the Pythagorean theorem says, okay, what I'm going to do is I'm going to take my legs, so I'm going to square them. So the first leg is 3, I'm going to square it. Plus, I don't know the second leg, I've used a question mark, so we'll square that. Those two things look kind of the same. So let me go ahead and use an X there, and we'll square it. And then the hypotenuse in this case is 5 squared. So again, the Pythagorean theorem It's the second thing. You got to remember, it's plug and chug. A squared plus B squared is C squared. So let's use our calculators if we need to. 3 squared, 3 times 3 is 9, plus x squared, 5 times 5 is 25. I've got to figure out what x is, and you're totally going to use your calculator for this. So the first thing I have to do is I have to get the x squared thing by itself. So I'm going to subtract 9 from both sides. And 25 minus 9 is 16. And then, with your calculator, if I know that x squared is equal to 16, what button in my calculator am I going to use to figure out what x is? Square root button, okay? It's this shape right here. It looks like a check mark with a roof after it, okay? That's the square root button. You don't know where your square root button is on your calculator, just see me after class. It'll take us 4.5 seconds to find it, and I'll show you where it is, and you can use it. So when you hit the square root button on your calculator, you get x is equal to 4. So that 4 is right there. So here's one for you. I'm going to have you do something similar. I'm just going to give, in this one, I'm going to give you the 2 legs. You're going to figure out what the hypotenuse is, and then we are going to go on to our next problem. So here's yours. Different shape of, I mean, it's still a right triangle, but it's oriented different, just so that you don't always think they have to be oriented the way I drew mine. And so this is, I've got a side of 10, I've got a side of 24, and I want to know what is the side across from the right angle. What's the hypotenuse here? So I'm going to call it x. All right, so here goes. This time I gave you something slightly different than the problem I did. The problem I did, I gave 1 leg and 1 hypotenuse, so we have to figure out the other leg. This time I've given you legs. You might say, how do you know that? Well, remember the legs are the ones that where the right angle is in the middle of. The hypotenuse is always on the other side of the right angle. Okay, so here goes. My first leg is 10, so I'll square that. My second leg is 24, so I'll square that. My third leg, or not my third leg, my hypotenuse, the side across from the right angle, I don't know, so I'll square that. And then the rest of this is just a calculator problem once you got the numbers in the right place. So 10 squared is 100, 24 squared is 5 something, 576. X squared, so that gives me 676. And when I hit the square root button, what does that come out to be? 26? Oh, nice and even. And it, oops, not X squared. So again, remember, follow any instructions that my math lab or I give you on the test as far as rounding is concerned, and we're good to go there. All right, so I'm done with the Pythagorean theorem. So we talked about perimeter, we talked about Pythagorean theorem. Last thing for the day, and then we're going to do some, just going to do as many examples as we have time for, is the idea of area of a figure. So the area of something is not now the distance around. In fact, the area is not a linear measure, it's a 2-dimensional measure. So for instance, if we're looking at this room, the carpet of the room represents the area. Okay, the area is the region between all the sides. Okay, that's what the area is referring to. So the area is the interior region bounded by the sides of a figure. So when you need to imagine it, I'm just going to put in parentheses like the carpet or tiles or whatever you have on your floor, linoleum or whatever. I don't know what you have in your house. I just told you the things I have in mind. So I'm going to try to give you a way. We're going to talk about, I think, like 3 or 4 or 5 different figures. I'm just going to give you a way to try to relate all of them so that it's less of a memory chore for you. So we're going to start with a triangle. Remember, a triangle has 3 sides. Just going to draw a generic triangle. There's nothing special about this triangle at all, even if it looks like there's something special about it. It's not intentional. So there's my triangle. So the interior region of a triangle is given by this relationship. The area of any triangle is this. It is 1/2 the base of the triangle and times the height of the triangle. The height is always the distance from the base to the other tip. So depending what is called the base of your triangle, the height is from that side to the tip of the triangle. There's your area of the triangle. Now, I'm gonna give us a couple more figures. The next thing we're going to do is called a parallelogram. A parallelogram has 4 sides. And the special thing about a parallelogram is both pairs are parallel. So here is a generic parallelogram. Nothing special about this other than the 2 pairs of sides are parallel. So you can see it's got kind of a lean to it. As an aside, special instances of parallelograms, rectangles and squares are both parallelograms. So I'm not going to give you a special formula for those. Okay, they're all the same thing. Okay, so a rectangle has both sides parallel, a square has both pairs of sides parallel, so they all meet this criteria. And here's what I'm going to do. You don't have to write this part down if you don't want to. I'm just going to draw like a little dotted line along. And then what I'm going to do is I'm going to divide this into 2 triangles. Oh, that's cool. I've got 2 triangles. Well, I already know how to find the area of one triangle. One triangle is the base times the height. Or excuse me, one triangle is half the base times the height. So what do you think 2 triangles would be? Just base times height. Yes. So what I'm trying to link in your mind here is once you've got the area of the triangle, remember, half base times height, a parallelogram is just 2 triangles glued together. Okay, so this is one triangle. This is a half the base times the height. This is a half the base times the height. So the area of a parallelogram is just equal to base times height. Now I know some teacher in the past has told you the area of a rectangle is length times width. The length and the width, those are just different names for the base times the height. Okay, so it's all the same thing. You don't have to remember anything new for a rectangle or for a square. They all fall into this criteria right here. So let me label them appropriately though. I know I drew my triangles here. I was just trying to demonstrate. So here's a new parallelogram. I'm going to call the base this bottom side. It doesn't always have to be the bottom, but the height is the distance between the 2 bases. So if I call the other side the base, then the height would be the distance from that side to that side. Okay, so that's my height, base times height. The distance between the 2 bases, yes. If I call this bottom one base, then the top one's also base, they're the same. And then the height is just the distance between the 2 bases. Yeah, that's exactly right. Great way to summarize it. Okay, so the last 4-sided figure that we have, so we've got the triangle, we've got parallelograms. The last four-sided figure, and then other than circle, that is all the formulas that you're going to have to remember. So triangle, half base times height. Parallelogram, which is two triangles, it's base times height. And then the third thing, I've already told you what this is earlier in the class. It's a trapezoid. And remember, a trapezoid just has one pair of parallel sides. The other sides can do whatever they want. So I think this is something like what I drew earlier. Doesn't matter. The top and the bottom here are parallel. The left and the right, they have no relationship. So let me label some things here for you. We're going to label the parallel sides. This parallel side I'm going to call base with a little, is that what our book does? Let me do the same thing our book does so that there's no confusion here that I accidentally give to you. Okay, yes. We're going to call this bottom side base with a little 1, B1, base 1. We're going to call the top, because these are not equal, okay, we're going to call this base with a little 2, B2. The distance between the bases is the height, just like the parallelogram. Okay, so notice here, here's the thing. On our parallelogram, the bottom and the top, they have the same length. Okay, so we just used base times height. On this figure, though, the bases don't have the same height, or excuse me, they don't have the same length. So here's what I'm going to do. I'm going to take the average of the bases. Okay, so the area of a trapezoid is going to be the average of the bases times the height. Now, this is my effort to make this memorable. Okay, and I'm going to write down what the formula is. If you just prefer the formula and you want to write that on a 3x5 card and memorize it, that's great. My triangle is half base times height. My parallelogram is base times height. My trapezoid is average of the bases times height because the bases are a different length. Okay, I've tried to put them all in the same sort of thing. Now, you might be thinking, what's the average? Or maybe you're thinking, how do I find the average? If I gave you two tests in this class and I said your grade is going to be the average of the two tests, what would you do to figure out your average? You add them up, divide by 2, right? That's what we would do. That's what we're going to do here. The average of the bases. I'm going to add the bases up. Base 1 plus base 2 divided by 2 times the height. That's the average of the bases times the height. All right, so before we get to the last thing is the circle. But before we get to the circle, we're just going to apply this. So basically, once you remember these formulas, however you need to code them into your brain, whether you just need to write them on 3x5 cards and quiz yourself, or whether I don't know, whether you need to put them to music and play it into your ears, I don't know, whatever works best for you retaining things, that's what you need to do. And then it just becomes plug and chug. So I'm going to give you a triangle, and you are going to find the area of the triangle. So here, this nice first, just a very relaxing example. Okay, nothing special about this triangle. So here we go. Here's a triangle. I'm going to tell you that this bottom side right here is 18. I'm going to tell you this side right here is going to be, let's say, 13. Let's give them units just for funsies. Let's call it yards. Find the area of that triangle right there. So remind me, what's the formula for the area of a triangle? It's what? 1/2 times the base times the height. It's probably a good idea to write that down every time for yourself. It helps you remember it when you use the tactile motion of writing it down. So now it's just plug and chug. 1/2. What's the base of this triangle? 18. What's the height of this triangle? Sure. You can multiply these numbers in any order. Half is 0.5 if you're using your calculator. So 1/2 of 18 is 9. 9 times 13, that turns out to be what, 117? Yeah. Now here's the thing I didn't tell you. So if you didn't get this part, that's okay. You're going to get your chance. Now, I should have written my units down here. Let me be a better instructor. Sorry. 18 yards, 13 yards. Okay, so now we don't have a linear measure. The units are not just plain old yards anymore. When you go to Home Depot and you're buying a little thing of carpet or some tiles or some linoleum, notice it's not given in just linear units. Yards times yards is going to be what? Yards squared or square yards. You can write either one of these two things for me. I don't care. I write it mathematically, yards with a little 2 up there, yards squared. Or if you want to, you can write square, whatever the units are, square yards. Okay. So what that's saying is if I had a little piece of paper that was 1 yard square, 1 by 1, and I lay it down, that 117 of those pieces of paper would cover that triangle right there. Here's another one. This is just going to be a fun little parallelogram. But what I'm going to do this time is I'm going to just try to make sure you understand the distinction between how the base and the height are related. So I'm going to tell you this about this parallelogram. I'm going to tell you that this side over here is, let's say, 8. I'm going to tell you that side down here is 11. And then this right here, I'm going to put dotted line right here, and we'll call that, let's go something like 7. No unit, but yeah, let's do units because I need to make sure that that is locked into your brain. So it's inches are the units here. So find the area of that. You have to pick the 2 appropriate things and use them to find the area. All right, so first, tell me the area of a parallelogram. How do I find that? It's base times height. That's great. All right, so now I have to pick the 2. So which one's the base? Why did you pick 11 as the base and not the 8? Well, it is a parallel side.
7 going from 11.
Yes, because the 7 is going between the 2 11-inch sides. That's why that one's the height. Okay, I'll redraw this figure in a second and show you. So we've got 11 inches is the base and 7 inches is the height. So 11 times 7 is 77. Inch times inch is square inches. Now you don't have to write this down, okay? But if I change this, okay, so here's my figure. Then if I had said this, if I had said this is like 14 inches. Now which one's the base? The 8, because now I've given you the distance from 1/8 side to the other 8 side. That's why that's now the height. Okay, so the height is the measurement that goes between the 2 bases that you're using. Okay, so yes, great question, great answer. All right, here's another one. I'm going to leave our buddy the trapezoid up there. So here's our trapezoid. Okay, so I've got this trapezoid right here. So let's go that the top here is going to be 17 decimeters. The bottom is going to be 31 decimeters. And then this distance right here is, let's call that 11 decimeters. And I would like you to find the area of that trapezoid for me, please. All right, so the area of a trapezoid is the average of the bases times the height. Okay, it follows the same format. Parallelogram is base times height, triangle is a half base times height. The trapezoid is the average of the bases times height. So the average of the bases is base 1 plus base 2, doesn't matter which one's which, divided by 2 times the height. Average of the bases times the height. So here we go. Base 1, I'm going to call 17 decimeters. It doesn't matter. You can use the 31 there. Plus base 2 is 31 decimeters. We'll divide that by 2. And then the height is 11 decimeters. So let's figure out the average first. I'm going to take this one step at a time. So 17 and 31, what is that? 48. 48 divided by 2 is 24 decimeters times the 11. And then when you pop that into your calculator, 24 times 11, I think is 264 decimeters squared. Square decimeters. And plug and chug. That's how we find our area.
Why is it decimeters squared? That's how you do that on my field.
Because our area is a two-dimensional unit. That's what the little 2 means, the square. There's both a, like if I'm standing here, I could go this way, I could go this way. There's two what physicists would call degrees of motion that I have. And so if I go diagonally, that is a combination of the 2 options I have to go straight or left. So that's why it's a square unit. And then mathematically, it's a square unit because decimeters here for the average of the bases, decimeters here for the height. One thing times the other is decimeters squared. Okay. Great question. Why is it a square unit? In fact, when we come back next week we're going to talk about volume. Volume becomes a 3-dimensional unit because not only can I go straight and not only can I go that way, if I had the ability as a 50-year-old man, I could jump, right? And I could go up. And so I have 3 degrees of freedom in that sense. Okay, so last thing, and then with any time left, I got a couple combo problems that I want to do. So the last thing is the area of a circle. So you see these things kind of add up, and I'm trying to craft this in such a way that, oh, that's a terrible, I could not talk and draw a circle at the same time, so there we go. So if I want to find the interior region of a circle, there's no good way like for me to have you remember this. I'm just going to nail it down here. The area of a circle, it's not given a special name. The area of a circle is that fun number pi that we talked about earlier times the radius squared. Pi times radius squared. So it's just plug and chug again. It's just using your calculator. So same instructions as before. Either use the pi key or 3.1415 if you don't have one. And then round to the 100th. And I'm just going to give you this circle right here, and I'm going to tell you that the radius is, let's call it 9, and let's call it, I'm running out of interesting units, so let's just call it 9 inches. So the area of this is pi times r squared, so it's 3.1415, or if you have a pi key, you hit that, times r, which is 9 squared. So in your calculator, if you don't remember order of operations, start with that exponent, do the 9 times 9 first, so that's 81, and then I'm going to multiply that by 3.1415, and that's 254.4615, and when I round it, I get 254.46. Since my units were inches, since I'm finding area, it is now inches squared. Okay, it's a two-dimensional unit. If you used the pi key, okay, just because I want to make sure everybody feels nice and settled, 81 times the pi key is 2, you would round to 254.47. Okay, so you're a little more accurate because yours was 0.46900, and so you got a little bit more accuracy on that. This is likely to be our last problem for the day. If we have time left, but we probably won't because I got to get back those tests. So this is our last problem for the day. It's a combo problem. You're going to see several of these on the homework. So here's what I've got. I've got a rectangle. And inside the rectangle, I'm going to draw a circle. The radius of the circle is going to be 4 meters. The length of the rectangle down here is, let's keep the numbers nice and relaxed, 10 meters. Here's what I want to do. I'm gonna kind of give you some verbal instructions to spur you forward. Here's what we want to do. What I have is I have a rectangle, and what I've done is I've drilled a hole in it. And so what I want to know, I'm shading it now, is I want to know what is the area of the black region, the part I'm shading black right here. Well, the height it's given, but you gotta kind of deduce it. Okay, so I'll mention that in a minute. But let's talk general process before I answer that question of where's the height. You didn't seem to give it to me, Berkster. So if I have a rectangle, we can find the area of a rectangle, right? What's the area of a rectangle? Base times height. So you can find the area of the rectangle. So the area, I'm going to write a little rectangle right here, abbreviate area of the rectangle, base times height. Great. What I've done then to that rectangle, that area, is I've cut out a circle. Can I find the area of a circle?
Yes.
Yes, it is pi r squared. Thank you. That was a very definitive yes, and I really appreciate it. Okay, so yes, we can. Here's my question to you. If I want to know the shaded region, what am I going to do with those two areas that I know how to find? Subtract them. Yes, you start off with the rectangle, you have that. Then you came along and you punched a hole in it, so you got rid of that. It's no longer there. So this is what's left. You're going to subtract those two areas. Great. The other question is, because you're going to see this on your homework, I don't see a height. Well, I know that the circle goes from top to bottom, right? You can see that in the picture. So if the radius of the circle is 4, what's the distance all the way across the circle, which is the height? Yes, great. Go ahead, figure that out. I'm going to give you 3 or 4 minutes to do as much of that as you can. And then I'll work it, and then we'll be done. All right, just for time's sake, I know you're probably still working, so I apologize. I didn't budget my time perfectly today. So the area of the rectangle is the base times the height. Well, the base is given. We can see that it's 10 meters. Okay, the question is the height. Okay, so I have to deduce the height because I've got this circle that goes from one end to the other. I'm told that the radius of that circle is 4. So the height is the same thing as the diameter of the circle. So 4 plus 4 would be 8 meters. And I've done that in red to distinguish it from the radius. So the height of this rectangle is 8 meters. So if you didn't see that before, if you didn't quite get, I hope that visual helps you. So the beginning area, what I started off with is 10 times 8 or 80 meters squared. But then we cut out this hole, we took some scissors or whatever. So now I've got to find the area of the circle. The area of the circle is 3.1415, and that's my approximation. The radius is 4 meters, and I'm squaring it. So that's 16 times 3.14. And when we round that to the 100th, what do we get? 50.27. Thank you. Remember, if you use the pi key, you might be a little bit different than that, probably a little bit more, maybe 50.28 meters squared. And now the thing that I do to figure out the shaded area, so I'm just going to make that note for your notes. The shaded area then becomes the area of the rectangle, which is 80, minus the area of the circle, which is 50.27. And what is that? That's 29 point something. 73 meters squared. Okay, you're going to see some combo problems like that in the homework, and I just wanted to give you an initial taste. I will probably start off class next time before we talk volume with another combo problem, just so that we can all feel good.